We are starting chapter 12 today, matrices. Big ideas for this section, for at least the part that we're going to go through, are data representation and modeling. Essential questions have to do with how can we use a matrix to organize data, and how can we use a matrix equation to model a real-world situation. So we used matrices a little bit when we were solving systems of equations earlier this year, and now we're going to go into a little bit more of how we combine matrices and use them in more ways. Section 12.1 is adding and subtracting matrices. I can add and subtract matrices, and I can solve matrix equations. Big ideas here. The addition and subtraction of numbers can be extended to matrices. So we're going to use a lot of the same properties that we talked about in Algebra 1 and that we use now as far as number sense and how we can put things together. Matrices can also be added or subtracted by adding or subtracting corresponding elements. So if we remember from earlier this year when we talked about matrices, the dimensions of a matrix are the number of rows and columns. Rows go this way, columns go this way. Each number in a matrix is a matrix element. In matrix A sub 1, 2 is the element of row 1 and column 2. So if I have okay, 1, 2 is going to be row 1, column 2. It'll be 4. Take note here, addition and subtraction property of matrices here, page 764. To add matrices A and B with the same dimensions, add corresponding elements. Same thing here, to subtract matrices A and B with the same dimensions, subtract corresponding elements. What they mean by same dimensions is if we have 2 rows by 2 columns, a 2 by 2, or a 3 by 2, or however, they both have to be the same. Okay, so here we have 2 rows by 2 columns, and here we have 2 rows by 2 columns. So they match up. Okay, we are going to either add or subtract corresponding elements. What that means is our first element, so here we have A sub 1, 1 and B sub 1, 1. When we're adding, we can take those two and add them. Sub 12, add them. A sub 2, 1, B sub 2, 1, those two we put together and add them. Same thing here. Sub 2, sub 2, there we go. And those two go together. So corresponding elements, same thing over here. We just subtract instead of add. But it's the exact same idea. We still put the same ones together. So, let's try it. Adding and subtracting matrices here, given C and D, which are both 2 by 3s, what are the following? C plus D. So C plus D I'm going to take 3 plus 1, 2 plus 4, 4 plus 3, negative 1 plus negative 2, 4 plus 2, and I'm going to take 0 plus 4. And I added them all together because of my plus right here. So when I simplify this, 3 plus 1 is 4. 2 plus 4 is 6. 4 plus 3 is 7. I have negative 3, 6, 4. Okay, Same idea when we subtract. For part B here, I'm taking C minus D. So C minus D, matrix C minus matrix D. I'm going to take 3 minus 1. And again, my signs are going to match. I'm going to take 2 minus 4. I'm going to take the element for this spot from C minus D, 4 minus 3. So they have to go from the corresponding spots, -1 minus -2. Four minus 2. And it's C minus D. So I take C minus D. C minus D. Element 2, 3, 2, 3, 2, 3. They have to match. Same spots go together in the same locations. So here we're going to get 2, -2, 1, 1, 2, -4. Okay. Try these. Here we have a 3 by 2 and a 3 by 2. So they're still the same dimensions, which means we can add them. So to take A plus B, we take the first element in A plus the first element in B. 24 plus 1. Corresponding elements go in the corresponding spot. -3 plus 2. 5 plus -4. -1 plus -1. And 10 plus 5. This is going to be here -15, 25, -1, plus 1, -1 plus -1 is -2, 10 plus 5 is 15. Matrix A plus B equals A minus B. I'm going to take an element from matrix A and subtract the same corresponding element from B. So -12 minus -3. -24 minus 1. -3 minus 2. 5 minus -4. -1 minus -1. And 10 minus 5. We can simplify these now. To -12 plus 3 is -9, 23, -5, 9, 0, and 5. And this right here is what we get when we take matrix A minus matrix B. Now, a matrix equation is an equation in which the variable is a matrix. So, solving a matrix equation here, we're going to look at page 765. And the first table shows the teams with the 4 best records halfway through their season. The second table shows the full season records for the same 4 teams. Which team had the best record during the second half of the season? So we have matrix A is our first half. and matrix, I'm going to go with C for the full season. Again, we can label these however we want. We need to know what was the second half. And this right here is the one that we're looking for during the second half. So we're going to take a matrix A plus B to get C. First half plus second half gives our full season. Right now, for A, actually I'm going to go ahead and solve this before I start plugging in matrices. So to get B by itself, I subtract an A from both sides. And I have B equals C minus A. Now I can substitute what I know. I know my values for C and A. Okay? Matrix C is going to be the wins for the season. I have 53 wins, 29 losses. 67 wins, 15 losses. 58 wins, 24 losses. And 61 wins, 21 losses. Matrix A, for the first half of the season, I have 30 wins, 11 losses. 29 wins, 12 losses, 25 wins, 16 losses, and 24, 17. Now, I can take matrix C minus matrix A. So C minus A, C minus A. C minus A, C minus A, C minus A, again, and I want to pick corresponding elements, C first minus A. Now I can simplify here. $23 and 18, 38 and 3, 33 and 8, and 37 and 4. Now, we're looking for which team had the best record during the second half of the season. When we compare these, remember these are wins, these are losses. We know it's not team 1. They had the fewest wins and the most losses. Okay, the team with the most wins was B. They also had the fewest losses, which means team B had the best record for the second half of the season. Team 2, sorry. Team 4 was close, but team 2 was our winner. I'm going to stop this video here and continue in the next.